Hello everyone, welcome back. I'm Sainath from 5th SEM. I'm studying computer science, data science. And today the subject is theory of computation. In theory of computation, the topic is pumping lemma of theory of computation. Pumping lemma in theory of computation. Before going to topic, please like my video. And we know about the introduction to pumping lemma. The pumping lemma is a fundamental theorem in formal language theory. It provides a necessary condition for a language to be regular. Understanding this lemma helps in proving that certain languages are not regular. These are not regular. This main purpose is formal language theory. It will use it provides necessary conditions for language to be regular. Understanding this lemma helps providing certain language. And we can see here one picture pumping lemma. Pumping lemma is used to prove that language is not regular. This this as we written in this point, certain languages are not regular. It cannot be used to prove that language is regular. And if A is a regular language, then A is a pumping length. P Now P such that any string S where S greater than or equal to P may be divided into three parts like S is equal to X, Y, Z such that the following conditions must be true. The first we can see this X, Y or I, Z belongs to A and Y greater than 0 and XY less than or equal to P. The next is definition of regular languages. A regular languages is one that can expressed using regular expressions or finite automata. Regular languages are closed under operations such as union, intersection, and complementations. Examples of regular languages include the set of all strings over a finite alphabet and simple pattern. And the first definition is regular languages. One can be expressed using regular expressions for finite automata. This match one, this match. This capture one and more instances and match between 2 and 4 instances here. And the next is the pumping lemma statement. The statement that for the any regular language there exists a pumping language. Pumping length will be one length. Any string as in the language with a length of at least p can be divided into three parts. The string can be written as S is equal to X, Y, Z with conditions on the length of Y and Z with conditions of the length of Y and Z. You can see here one picture statement of pumping limit. For every regular language L, there is an integer n such that for every string W within L of length L of length greater than or equal to n, we can write W is equal to xyz such that y is the label along first cycle on path label W. You can see here 1 xy is less than or equal to n, y greater than 0 for all I greater than or equal to 0, xy power I is in L. Understood? Next is conditions. The substring y must have a length at least one, at least one, meaning it cannot be empty. The combined length of xy must be less than or equal to p. Okay, the combined length, must be less than or equal to p. For any integers I, g, e 0, the string xy into xy power of I z must also be the language. And this picture I have shown past, right? And next is importance. The pumping lemma is a crucial tool for proving languages are not regular. It provides a systematic way to analyze the structure of strings in a language. By by successful applying the lemma, one can demonstrate the limitations of finite automata. And next is applying the pumping lemma, where we can apply. To use the pumping lemma, start by assuming the language is regular and identify a su- suitable string. Next, decompose the string into parts x, y, z, x, y, z according to Lemma's condition. Finally, show that for some I, the string like this x, y power I, z falls outside the language, contradiction, leading to contradiction. And one example, this is a statement of that a power n, b power n is n greater than or equal to 0. The language of string with equal number of a's and b's is known as non-regular. The language of strings with equal number of a's and b's is known to be non-regular. Assume it is regular and let p be the pumping length. Choosing the string s is equal to a power p, b power p. Okay. Now decompose S leads to contradiction when pumping Y as it disrupts the balance of A's and B's. Here I have added the picture but it was not showing. Then limitations of pumping lemma. The pumping lemma cannot prove that the language is regular. Okay. It can only show that the language is not regular. Some non-regular languages may not exhibit clear pumping structures. Understanding these limitations is essential for effective applications of the lemma. And next is relations to other theorems. Relations to other theorems. The pumping lemma is closely related to other concepts in automata theory, such as closure properties. It complements the Nerodi theorem, which provides the different methods for proving non-regularity. Together, these tools enhance our understanding of regular languages and their boundaries. Okay. And next is conclusion. The pumping lemma is a powerful tool in the theory of computation for analyzing regular languages, proving non-regularity using this lemma depends understanding of language structures. Mystery of the pumping lemma is essential for students and professionals in computer science and formal language theory.